Welcome to YQ Academy, SQL, Interview Questions and Answers. 1. What is subquery? Explain properties of subquery. A subquery, also known as a nested query or inner query, is a query that is embedded within another query. It is used to retrieve data from one or more tables and provide the results to the outer query for further processing. A subquery can be used in various parts of SQL statement, such as the select, from, where, or having clause. Properties of subqueries. 1. Enclosed within parentheses. Subqueries are enclosed within parentheses to distinguish them from the outer query. The result of the subquery is treated as a temporary table or virtual table that can be used by the outer query. 2. Executed first. Subqueries are typically executed before the outer query. The result of the subquery is used as a source of data for the outer query, allowing for more complex and refined data retrieval. 3. Can be correlated. A subquery can be correlated when it references columns from the outer query. This allows the subquery to be evaluated for each row of the outer query, providing a way to retrieve related data. 4. Can return a single value or result set. A subquery can return a single value when used in a context where a single value is expected, such as a comparison operation. Alternatively, a subquery can return a result set with multiple rows and columns, which can be used for further processing or joining with the outer query. 5. Can be used for filtering, sorting, or aggregation. Subqueries are often used to filter the result set based on specific conditions, sort data within the result set, or perform aggregation operations to calculate summary information. 6. Can improve code readability and maintainability. Subqueries provide a way to break down complex queries into smaller, more manageable parts. They can enhance code readability and maintainability by allowing logical separation of different data retrieval or processing steps. 2. What is user-defined functions? What kind of user-defined functions can be created? User-defined functions (UDFs) in SQL are custom functions that you can create to perform specific tasks or calculations. They allow you to encapsulate a set of SQL statements into a reusable function that can be called from within SQL queries, just like built-in functions. UDFs enhance the functionality of SQL by providing a way to extend its capabilities based on your specific requirements. There are 3 types of user-defined functions that can be created in SQL. 1. Scalar functions. Scalar functions return a single value based on the input parameters. They can be used in SQL expressions wherever a scalar value is expected, such as in the select statement, where clause, or as part of calculations. Scalar functions can accept multiple input parameters and perform calculations or data manipulations to produce a single output value. 2. Table-valued functions. Table-valued functions return a table as the result. They can be used in the from clause of a query and treated as a table, allowing you to join, filter, and manipulate the returned data. Table-valued functions can be further classified into 2 types. Inline table-valued functions. These functions return a table variable directly as the result. They are defined using a single select statement and can be used in the from clause like a regular table. Multi-statement table-valued functions. These functions return a table variable using a series of SQL statements. They are defined using begin and end blocks and can contain multiple SQL statements. The result is stored in a table variable, which is returned at the end of the function. 3. Stored procedures. Although not strictly considered a function, stored procedures are a type of user-defined object that can also be created in SQL. Stored procedures are used to encapsulate a set of SQL statements and perform a specific task or operation. Unlike functions, stored procedures do not return a value directly. They can have input parameters and can modify data, perform calculations, or execute complex operations. 3. What is identity? Explain its features. The identity property is used to automatically generate unique, sequential values for a specific column in a table. It is commonly used to assign a unique identifier to each row in a table. The identity property is often applied to primary key columns, but it can be used on any column where unique, sequential values are required. The identity column is defined with a data type, such as int or bigint, and a starting value and an increment value. Each time a new row is inserted into the table, the identity column's value is automatically generated based on the specified increment value. Key features of an identity column. 1. Automatic value generation. When a row is inserted into a table, the identity column is automatically populated with a new value. The database engine handles the generation of sequential values, ensuring uniqueness within the table. 2. Uniqueness. The values generated by the identity column are guaranteed to be unique within the table. Each value is different from all other values in the same column. 3. Sequentiality. The identity column values are generated in a sequential manner, following the specified increment value. This means that the values will generally increase or decrease in a predictable pattern. 4. Non-modifiable. Once an identity column value is generated and assigned to a row, it typically cannot be modified directly. This ensures the integrity of the unique identifier for each row. 4. Which TCP/IP port does SQL Server run on? How can it be changed? By default, SQL Server runs on TCP/IP port 1433. However, it's important to note that the port number can be different depending on the specific configuration of your SQL Server installation. To determine the TCP/IP port number that SQL Server is currently configured to use, you can check the SQL Server Configuration Manager or use the SQL Server Management Studio (SMS). To change the TCP/IP port that SQL Server is running on, you can follow these steps. 1. Open SQL Server Configuration Manager. 2. Expand the SQL Server Network Configuration section. 3. Select the specific SQL Server instance you want to configure. 4. Right-click on TCP/IP and select Properties. 5. In the TCP/IP Properties window, go to the IP Addresses tab. 6. Scroll down to the IPOL section and locate the TCP port field. 7. Update the port number to the desired value. 8. Click Apply to save the changes. 5. What are different index configurations a table can have? 1. Clustered index. A clustered index determines the physical order of data in a table. A table can have only one clustered index. It reorders the rows in the table based on the indexed columns and is particularly useful for optimizing range-based queries. When a clustered index is created, the table's data is physically reordered accordingly. 2. Non-clustered index. A non-clustered index creates a separate structure that contains the indexed columns and a reference to the actual data. Multiple non-clustered indexes can be created on a table. Non-clustered indexes are helpful for improving the performance of specific queries by allowing quick lookup of data based on the indexed columns. They are generally smaller and require less maintenance compared to clustered indexes. 3. Unique index. A unique index ensures that the indexed columns contain unique values across the table. It provides a fast lookup for unique values and enforces data integrity by preventing duplicate values from being inserted or updated. A table can have multiple unique indexes, and they can be either clustered or non-clustered. 4. Composite index. A composite index is created on multiple columns instead of a single column. It allows queries to efficiently search based on a combination of the indexed columns. The order of the columns in the composite index is essential, as it affects the index's effectiveness in query optimization. 5. Filtered index. A filtered index is a specialized index that includes only a subset of the rows in a table based on a specified filter condition. It can be used to optimize queries that frequently access a specific subset of data. By including only relevant rows, filtered indexes reduce index size and maintenance overhead. 6. Included column index. An included column index extends the functionality of a non-clustered index by including additional non-key columns in the leaf level of the index. This allows covering of additional columns in query execution without the need to access the base table, improving query performance. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.